Hi, as you can see, I'm still in the garage and my crutches is standing behind me, and I'm still about 2 weeks away before I can, do anything with my foot except just lay it on the floor. And this is an episode where I do all the things I need to do before I can test the amplifier, or at least I will try to make everything. But mainly I will see and make the power supply finished. But before I can finish the power supply, I will give you some tidbits about this guy here. That is my Variac transformer thingy. And this I use to slowly increase the voltage when I test power supplies, and I also use it to test all the equipment. So it's been some months since I last used this, so I'm going to walk you through that. And I'm going to make the rectifier circuit and circuit for the smoothing capacitors, and that's so far I'm going to get in this video. I still think it will be a rather long one and maybe a bit less comments than usual. I will try to fill in the blanks with some music. You can write a comment below if you prefer me talking and giving you some insights all the way, or if you prefer the music. Of course, if I'm going to give you insights and stuff all the way, then it really has to be done some of the video in fast forward. I am good at talking, but not for this amount of time, and the amplifier circuit thingy will be long debated before I'm finished with this, if I'm going to show you the video in real time. And as you can see, I'm using my Rode microphone. Rode is the way we see it in Norway. And I will check how the sound quality gets in this video. So if it's good, I don't need to make any adjustment, but I'm still open to do adjustment of this. So I used to say to the bench, but I am at the bench, so I will just switch to maybe I first take and go through the Variac thingy. This here is a doohickey I haven't used in some time. This is my Variac, and I bought this unit, the transformer itself. It's at least 17-18 years ago. And I've been using this on and off all the time since, but I actually done some rebuilds and some repairs on this thingy. And as you can see, this is placed in a case. There is a lot of wiring and nonsense in here, but this is actually a reworked old micro ITX PC case. I just gutted the power supply and used the fuse and the ISC connector. Or probably I didn't use the fuse either, I just put in a new fuse. And I also have a fuse here for the secondary. So I just have the input fuse and I have a fuse on the output. And if I turn this so that you can see the front, I have to have it on my desk here, so excuse me for the close-up here, but this is the transformer part, and here I have outputs, and I have two instruments here to show the voltage and also the output current. This output current, I never really got it to work as I hoped. This should be from 0 to 3 amps, and it does show some current, but I can't imagine that is right. I didn't tried to do some calibration on this, but it didn't pan out. And I also have two indicator lights. This is for power on and the switch here. And this switch here is for a boost that is embedded into the transformer here. Because when I activate the transformer, you have one output here that is doing the transformer in overdrive. So this normally goes to from 0 to about 238, what is what I normally have in my outlet. But if I turn this red knob, I will get up to 280 volts. So a bit of over voltage from the transformer there. So there is an extra winding that is coupled in to boost the output signal. Otherwise, I just have some doohickeys here. This is a capacitor and some other stuff to bring down the voltage, and the rectifier to drive these two LEDs. This is just normal 8mm LEDs, I think, or 10mm maybe. And I have an outlet here. This outlet is the standard Norwegian style outlet. This is actually made from the Norwegian company Elko that did this kind of things. And I did have a fan in here. I never saw the point because this does not get warm enough to warrant the fan, but it's possible that I can put it in. And I also had a small transformer or power supply up here to drive the fan. And also in the first version of this, I did try several digital solutions for this, and it worked kind of okay for the voltage. But none of the options worked very good from 0 volt and up to 300. So this analog dial works much better. And of course, I'm not normally using this without a lid on. And this is the standard. The camera turned into automatic zoom mode. There is something that is letting go in my my setup here. So I will just cut it here and I will put on the lid and show you that. And by automatic zoom mode, I mean that my camera stand is sagging, and that really fast. Yeah, now it's fully assembled and turned into one unit again. And I will use this when I'm going to design the power supply, because when I fix this, I need to make sure that I have these wires right. There is a color code here actually, so I do think it's like so, if I don't remember wrong. So these two should be connected together, and these two should be the other ones, and this is of course the primary side. So I'm going to show you the design of the power supply. So I'm going to show you how this looks in my poorly drawn schematics before I do anything else. So let's switch to the graphics mode. Yeah, what you see here is my power supply design, and here is the cord of the transformer, and you have the primary mains here. So this is the 230 volt, and you have a fuse. Of course it's not put in, and you have a switch. And normally when I do these kind of things, I use a dipole switch so that I switch both leads here. And that's the primary side taken care of. And then it's the secondary side. And I have just guessed as of now that this is following the normal pattern for how this is wired. Because when you have these windings here that deliver sinus, and you are going to make sure that you can connect them together and have them the same phase. If they are opposite, if they switch opposite this, you will get twice the voltage. But if they go exactly the same like so, and you connect them up together, then they will cancel each other out. And the rule of thumb that I learned years back is that the Swedes should unite, and I learned this in the Swedish version of the Elector magazine. So you see, the yellow and blue wire should come together to make a neutral center tap and have twice the voltage. So you may have to make sure that the phases fit together. I will show you a diagram of how this should be when you take this out. But here you have a rectifier bridge. You ground or put these two to common, and you take the other and feed it into the rectifier, and you take out your positive on the cathode side, and you take out your negative on the anode side. And here I have put in some capacitors. Normally I would say 10 nanofarads. These are to suppress the noise that is coming when you switch these diodes. It normally don't matter that much with 50 Hz, but you can have some noise on your mains, and it doesn't hurt anything that you have these capacitors here. I've seen these value from some picofarads, 100 pico to 100 nanofarads for what people put over here. And you do have some, this is the same, so if you follow this, each of these 4 capacitors here, they stand in parallel with one of these diodes. And you have your smoothing caps here, and you have 100 nanofarad on the output there too. You can do it like so. On these here, I'm going to use a couple of capacitors in series, I think, but I do think that the ones I do have in my kit here now is 6,800 farad, and I do think I have 4 of them, and that is actually more than enough for this, but I'm also going to put in some smaller ones in parallel. And you do have fuses on the output. This is really not optional, because if something goes wrong with your amplifier, it's good to have this fuse here. But of course, the fuse main duty is to protect itself, and every transistor or active component out there is more than willing to sacrifice themselves to save a fuse. So of course, when you is going to have something that draws maximum 100 watt, of course ours is not going to deliver 100 watt when you have the lowest voltage. But let's say that you are delivering 30 watts. There is some power going through these fuses, and a lot of things can go wrong on the other side. So I do have to have a fuse here that can deliver this current, and you have this one like so. So that means that you want to have the I alone on one side. You do have to divide this by U, so it's P over U, and that means that if you are going to have 30 watts, let's say we are going to have 35 watts, because if I have 35 volt there and divide that by 35 volt, you is going to get 1. So that means you do have 1 amp here to deliver 35 watts when you have 35 volt. So, but that's enough yapping about that. I'm going to explain something that I just briefly touched into last time, and that is actually what this circuit out here is doing for good. I said correctly enough that this is to prevent oscillation, high frequency oscillations, but my brother pointed out to me that this works actually by smoothing out the impedance of the output circuit. So when this is reducing the impedance with increasing frequency, you do flatten out this curve. So instead of you having it rise like so and get unstable when it comes to high frequency, you actually smooth out the impedance over a higher frequency span. So that is how this circuit works, and I had actually forgotten, but my brother remembered that this was a Subel network, and it's also called a Boucherot cell. So just some additional information about this circuit, and it's also to say that this does not matter that much for the functionality of the amplifier. So when we put in the 10 ohm here, I don't think it will matter that much. We will stabilize it on a bit higher impedance here. That's it. But I do think it will make it better suitable to drive 8 ohm speakers than a 4.7 ohm resistor. So 10 ohms might suit our use better because I'm going to use this on my normally 8 ohm living room speakers. So then we have to go on to see what we can do with the power supply. Yeah, to make a test of the amplifier we have made, we need some more things. This is already shown. It's a 2 times 25 volt AC with 220 volt input transformer. I do have some other doohickeys here. This is not a complete picture, by the way. I also have some other stuff. This is a rectifier bridge. This is the, yeah, there should be some markings here, but I can't see them. I don't know if this is a knockoff or if it's the real thing. The markings has gone away on this. And this should be at 2510. It should be good for 1000 volts in the opposite direction and at least enough amperes to keep us by. And I will need 2 of these thingies. Actually, I do think I have 4 of these. These are 6800 microfarads, 63 volts. And I also have some 2000 micros, that is 50 volt. And I'm also going to apply some lesser capacitors, 100 nanos or something on top of these to take the higher frequencies. I do have a fuse holder for a 20 millimeter glass fuse. And I do have some of these. This is not wire nuts, this is the Waco type of things. And I'm going to scrape off the lacquer that's on top of these leads here. You can see the red color that's also on the transformer. This is quite sturdy lacquer that's on top here, and I'm just going to scrape this away and use this to connect this up. And I'm going to have some spade connectors to attach to these other things, but for these I need to solder wires, and further on I do have some more stuff. This is a newer type of, not Waco, but Vago was the name of this, sorry. This is an newer type, and I do have some with 3 pole for the ground and these other here. And I also have this screw terminal thingy. I don't think I'm going to use that. I do have some 0.5 or 0.75 lead. This is older, so I do think it's 75. And I also have some thicker wire here. This is new old stock from back in the day. This is bought from Elfra. And this is 1.5 millimeter. And what more do I have here that is important for the testing? Yes, I do have this one that this was soldered up by my brother some time ago. And this is to test out amplifiers. So this is just to put a load on the output of an amplifier. And this was when I was rebuilding some amplifiers some time ago. And these are 3. Actually, we can use the fluke and I can measure how big these are. I do think it was 3.3 that was on the markings. But that's an easy thing to figure out. Just put these so it doesn't have the glare. This is the total, 10 ohms. And then each of these is 3.3, so that's probably correct. Yeah, this measured 3.4. 3.3. So this is going to have some load on the output, and these are 5 watt each. So when you have these in series like so, they will be easily able to dissipate 15 watts, and I can also put this in water to have them cool down. So that's an essential part. And I'm just going to connect up this and try to make it as safe as possible to do the actual test. And this fuse I'm going to place here on the input. And I'm also going to use my variac transformer to take up the voltage slowly when I test this the first time. So then it's just to get going, I think. Yeah, I forgot to mention this one. This is a side cutter made by Sandvik of Sweden. And this is to cut the more heavier stuff that these thin electronic side cutters is not able to handle. So then I will start cutting up things. I'm going to use this as the power cord during the testing, and this is a KOJRO plug, they're called. And this is normally for about 2 amps something. And let's say what is that, 2.5 amps, 250 volts. And in Norway we don't normally have the power system where you have a grounded neutral wire. So in Norway we do have N and L, and we have a separate ground. And I don't need this ground when I will be testing this. In the chassis, when I'm going to mount this, I'm going to have an invert connector to ground the chassis, but not for the test. So I just cut away that thingy and will dismantle this probably better than this, because I did cut into the wire. Like so. And for this, will I bother to go and get one of my wire strippers? Of course not. And for this, of course, one of these will go into the fuse, so I might cut one of them a bit shorter. Like so. So that's the power connection, and this will go to here, and from this it will go into some of these connectors that will tie up to this. So I need one short. I might use this, or I might get a slightly longer one to connect up this. I do have the same kind of wire just here, so I'm just going to cut the piece to do as so. Yes, I do have to check how they look. Oh, this was very silicone-y. These are also covered with some lacquer, so I need them to be scraped up and probably in. It's the best way to make sure that we actually have bare copper on this. You can see this was red and this was coppery in color, so it will be easier to identify if this is copper or not. Yeah, but I will just start soldering this. Like so, and then it was the wires on the transformer. So they're good and tinned. That means when I'm putting them in here, and so now this should be ready on the input side to make a test. I of course need to add a fuse. I need my son to go and fetch the fuse for me because I don't have fuses up here, but that's taken care of. And then it's this mess. And as we remember from the walkthrough, this is dedicated colors. It is still the same. We need to scrape this off a bit. Maybe I can use this one. It's quite sturdy. It doesn't scratch easily. Maybe a knife would work better. Yeah, it would, but even here I can feel the resistance. I will try to tin this now. And see how it goes. Yeah, actually that got quite decent. So I will just do the other 4 off camera. Yeah, and now I have tinned these leads and I'm putting on the Vagos. Actually this was melting easier than the other colors, so I do need to put some heat shrink tube or something on these two to protect them. And of course this plastic is kind of old, so this transformer is not from yesterday, as you might remember. The datasheet was from 1984. So that's the transformer part. And then we need this part. In here I need some spade connectors, 6.3 millimeters, same as used in the automotive industry. So I'm just going to solder up some leads for this. I'm not sure yet what I'm going to do to hook up the capacitors, but the leads from this and to the side here with just the inputs. All the writings on this is totally gone. and it was there, because I just know that this is plus, that means that this is minus, and these two here is the AC in. The plus is the one that is twisted on these. So we're just going to connect up some spade connectors for these two first. This is for crimping. I don't have the proper crimping tool here. I will just check that these go on. Oh. Maybe use this one so I don't cut my fingers. Yeah, they are okay. Not as springy as I would hope, but they are working. So I will just find some leads for this. I'm just doing a manual crimp here with these pliers, and I'm going to solder these anyway. And I'm very curious of how this solder would stick to these. These are plated with something, and they do look kind of okay, even though they are El Cheapo thingies. Again, I am amazed over how quick this soldering iron is heating up, and this even amazes me more. This spade connector, it seems like it's sticking very good to solder, so I think this will be a very good connection. That was both of them soldered, and I'm going to feed them into the outputs from the transformer, and this is the red and gray wire from the transformer that's going to feed into the rectifier bridge on the AC inputs. And I'm going to take some heat shrink tube, and I'm going to try to do some color coding, so this will be yellow, I think. I don't have a heat gun here, and I don't have my hot air desoldering station, so I'm just using the side of the soldering iron to heat up the shrink tubes, and it works okay. I do this a lot because it's the easiest heat source available when you are doing soldering, and it might be some slight discoloration, but it usually works quite okay. Just to have a reference point here, I'm going to put one wire into the Vago that is the common or neutral or ground wire here. And I'm using a blue wire, not best practice, but it's what I have. Yeah, about the capacitors, I 3D printed this batch with things here, and I just glued together two of these pieces, and I've just they're just like so. It was a design I just found, and I'm just placing the capacitors in here like so, just to have something to mount them on. And I'm going to try to solder some wires here. One for the plus side, one for the negative side, and one for ground. And I'm not totally sure how I'm going to connect the wires at the end. Maybe I just use these terminals and stuff, but I will just take the insulation away from these wires, so I will be able to I need to solder these capacitors here. I do have this one that is 470 microfarad, and I also am going to take some 10 nanos or something and just solder them in here. I'm just going to take the insulation off these wires, I think. Just like so. This is in European terms 2.5 in square, or something between 14 gauge or 13 gauge in the American system. And just going to do the same with this one. This is taken from installation wire that you normally run in your house. Just some piece I had lying here, but this is pure copper. It's not something aluminium or iron clad something. This is pure copper. And I'm going to just bend this up a bit. I lost the footage here, but I bend up this, yeah, like about so, I think. And have this connection here. This is the 0 ground wire. And if I have the positive wire here and the negative down here, when I'm making this like so, I'm able to solder on these capacitors up here on each side. And I also have these small ones here, maybe one on each here. This is the 10 nano. I don't need 4 of these 470s. It's just to take away some of the switching and more high frequency noise. Then will be, these will take the 50 and 100 hertz signals, and is the reservoir capacitors for the amplifier. This is more noise suppression. So I'm not going to use these. Did I have any spades I could have connected them here? I can connect these and fasten the wires with screw terminals, or I can just take some other terminals and fit them on here. I'm not really sure yet, but of course I can solder this on first and care about that later. But I wonder if I will lift this up like so when I do the solder, so to keep away some heat from these capacitors. Yeah, I see my camera is sagging. I will try to just lift it a bit. Yeah, I can see my camera is sagging, so you will get more and more of a close-up. This is also some El Cheapo terminals that I have lying about, and of course I can use this and just solder them on like so, and I will fit the connections here with screw terminals, with just the same terminals, and just put the screw in and clamp them together like so. But I'm not sure that I will bother with that. Maybe I just take the wires and I solder them straight on. So what will I do? The first thing I will do is actually to make room for solder this, and I have these wooden pieces here that I will place like so to use to keep the distance from these terminals. I will plug in my soldering iron and turn it on like so, and something like so. I'm not sure if this is going to conduct so much heat that I'm going to desolder this from every time I touch something other with the soldering iron, but it might be. Oh, didn't turn on. I haven't really figured out this user interface yet. Well, 360 degrees. I still think I will be pushing the limits of this soldering iron, but I have still yet to find it because this is doing just fine here. This is quite the thick cover and long strand, and this is good soldering. It's actually not bad, even by my standards. And oh, it was hot. Yeah, just let's solder it like so on the outside, and I can bend it a bit afterwards. Maybe I should put some pressure on this to keep it steady. Now I even have more cooling on this soldering, but it works like a charm, even though. Yeah, like so. And I do have these small ones that I want to solder onto here. Maybe just like so. One great thing about this soldering iron is that it's not magnetic. My Veller with the magnetostat, it has a magnetic tip. The tip is never fully demagnetized, so when you solder small components like this, they tend to stick to the soldering iron. So this is really nice with this one. Yeah, you can see my camera is still sagging. Try the same strategy here to keep this in place. Yeah, like so. Now I have soldered this together, and we should hide the negative, and we could have the positive output here and the ground here. And of course I could have done something to insulate this, put on some heat shrink or something, and I might do that on the pieces that stick out here if I'm going to make this. Oh, this actually got loose. Was that actually my first cold solder here, or was it getting loose when I soldered in the extra capacitors? Yeah, like so. I will just let this cool down a bit, and I will try to solder on some of these leads just to test, and probably just for the test fit. Yeah, maybe we use some screw-on terminals for that. This is just the leads I'm going to use as yeah, maybe temporary and maybe permanent connections to this. And this is 1.5 square millimeter lead, and it's two different kinds, but they have the same thickness on the wires. And I need 3 wires, one for ground, one for plus 5 volt, and one for, of course not, plus 5 volt, plus 35 volt and minus 35 volt. And I'm just going to connect this up. I'm going to solder on these leads on the amplifier side, and I have to adjust the lengths and stuff on this afterwards. But first, I'm just going to take these. I need 6 of these, one for both wires, and on this end, temporary, I'm just going to cut these back, and I'm just going to solder the lead straight on this. So I'm just going to dismantle these ends, and after that I'm going to solder on these pins, and I'm going to use some shrink wire just to mark these connectors and to tie the wires a bit better together. This El Cheapo wire stripper is kind of a strange beast. It has some American gauge on this side and some millimeters on this side, and it don't add up at all for the European standards for millimeters. Yeah, now I will prepare this for soldering with some heat shrink tubes and making this ready to solder on. Oh, it seems like one of the spade connector has gotten away. Maybe have slipped out on us. It seems like a lot of work to do just for a temporary test, and it's not really that. I'm going to use these wires when I am actually going to mount this in a box or something. So it's not the permanent. I will have to shorten in these leads and make some wire management, but otherwise I will use what I can of what I'm doing now. And now it's time for soldering this up. I will first just prepare the wires and I will solder it on the capacitor bank afterwards. Yeah, using the soldering iron to shrink these heat tubes does not bring out the best in them. They look kind of wrinkled. The color scheme I'm trying to run with here is the yellow and green. That's kind of a standard for the earth wire. I'm using that for the ground wire or the 0-volt neutral wire, and I'm using red for the plus 35 volts, and I'm using blue for the minus 35 volt. It's not totally consistent, but to keep a semi-consistent scheme, that's what I'm running with. Now let's prepare the capacitor bank, and we have to snip off some of the rather lengthy copper wire that's sticking out all over the place. I'm not doing so much measurement here because this is where I'm going to resolder the wires if I have to make them shorter when I mount this into a box. And this green heat shrink tube here, it's kind of too tight on here, so it's melting just with the heat when I'm soldering, so I have to do something here, maybe add another one on top. And here I run into a problem. I don't have any thicker green heat shrink tube, at least up here in the garage, and the wire is getting, the insulation got a bit mangled when I soldered this, so it's too thick to get this on. So we just have to make do without green on this one. Ah, look at that moron. That's some movie maker. Is keeping all the action almost outside of the frame and in the lower part of the picture. I try to entertain you with some music, but it will last for more than 3 minutes. So you can just skip 3 minutes if you don't want to see the soldering action here. Yeah, it's time to prepare for some testing, and we have the main transformer here connected up to a lead that can connect to the mains. We only need to add a fuse. And for testing this, I have a slow blowing fuse, and I'm just testing this with a 500 milliamp fuse. If there is something seriously wrong, it will probably break anyway, at least if the fault is on the primary side. If the fault is on the secondary side, we have to do some calculations to see if this fuse will break or not. But anyway, just let's get on with testing. With my current possibilities for camera setups, this kind of looks awkward, but this is my Variac transformer again, and I'm setting it so that it will be about in the middle position. Yeah, I'm hooking it up to the mains via the IAC14 connector, and it's kind of strange. You can't see the light in the LED, even though it's turned on, and it's also almost impossible to see from this direction what the voltage on the voltmeter is. But I'm going to connect up my fluke so we can see what the voltage on the outputs are. Yeah, I'm getting some mixed results here, between 5 and 6 something volt, and it's drifting a lot. And if I measure here against the center tap, it's something 5. So I do think I need to connect this better up so that I will have better connections and can have steady results on the multimeter. And as usual, I'm messing this up with keeping some of these things outside of the frame. But what I'm doing here is I'm taking off the plastic thingies in front of my measurement leads, and I'm disconnecting the rectifier bridge, and I'm going to try to hook the multimeter straight up to the output, just to have the open no load voltage. Yeah, the voltage, no, the maximum voltage I get out of this, and this is the same that's should go into the rectifier bridge, is 23 volts. And I'm cranking this up now, and the maximum I will get here is with the 1-to-1 to the mains voltage, because I don't have the boost function on, and as you can see we are at 60 volts here at maximum. But you must keep in mind that this is an open voltage with no load at all, so this voltage will drop when we close the circuit and put a load on this. And as you can see here on the center tap, I get about 20 volt and I have 40 at the maximum, so that is really good. That means that we do have a neutral center that is half the voltage of the other limits. And now I will connect up the rectifier bridge, and I will try to measure the open clamp voltage on the rectifier bridge. And remember, here I don't have any capacitors on the output, so I don't have any smoothing. So it's just the multimeter's internal capabilities to measure this voltage we do have here. Yeah, and the minus voltage is of course me just having the leads the wrong way around, but 42 volt is about what we could expect from this. So I'm just going to hook up the rest of the circuit and we can measure from there. And now we are ready to connect up this doohickey, and this is of course my capacitor and wire harness for connecting up power to the amplifier. What we must be really sure on now is that we don't hook up anything backwards, so we are having some exploding capacitors here. That could be kind of awkward, so let's just make sure that we have everything right before we hook up this. And let's get rid of this blue wire that was connected to the neutral or ground wire, because we don't need any confusion with the minus 35 volts and the ground plane. Yeah, let's just try to hook up the measurements lead carefully and don't short out anything on the capacitor block. And we are now slowly ramping up the voltage over the capacitors. Yeah, just to both prime them and don't give them a shock, and to be able to make an easy exit if something is wrong. There is something here that we kind of forgot. We don't have any bleeder resistance over this, so the capacitors will very slowly drain when you disconnect. And now they only have the multimeter's high impedance voltmeter input to drain through. So you can see here it's slowly ramping down, but we need to connect this to a resistor network, both to have some load and to be able to bleed the circuit so that we don't have high voltage on the capacitors and short them by accident. We can connect up this resistor network here. This is our 10 ohm 15 2 times 10 ohm 2 times 15 watt resistors. They will be able to bleed out the system. But if we connect this up to about 80 volts and 20 ohms, if you connect them in series, that will be some current. And just so you understand what we are talking about here, this transformer is a 120 volt amp transformer, but of course it will be able to deliver more over a short time span before it gets ruined because it gets too hot. But if we are maintaining 80 volts and over this resistor we are going to get about 320 watts, and of course we are not going to do that, but we might be able to deliver in the size of about 160, and if we do that we will burn these resistors very, very fast. So we can't increase the voltage all to the top. With 24 volts we are pushing, I do think we have about 29 watts or something, about 30 watts delivered into the resistors now, so they are at their maximum with 24 volts. You can also see that they are bleeding out really fast. What the heck, I think we are going to give this a turn until we can smell that the resistors are getting really hot. See how far we get before that happens. And by now I can feel that they are getting hot. 45 volts into 20 ohms. That's 101 watt. So we are giving these resistors about 3 times more than they are able to stand over time. So I think to test this with the highest possible voltage we need a bigger resistor that is able to handle the voltage without maxing out on current. And to mangle up a line from Crocodile Dundee, do you call that a resistor? This is a resistor. This is a 250 ohm resistor that can take 250 watts over some time. And I actually bought this way back to test the Variac transformer, because it would be able to deliver out about 1 amp, and the maximum for this Variac transformer is about 3 point something amperes. So it was just bought as a test, and I've used it in a lot of things afterwards. But let's quickly get this connected up so we can do some tests with the full voltage on the capacitors. Yeah, then everything should be okay to just do a test, and I do think that we will reach about the open clamp voltage that we have foreseen for about 80 volts, but maybe just slightly under. And 80 volts into 250 ohms, that is about 25 watts. So even though we get something a bit less, we should be okay. And it maxes out about 78.2 when we are drawing about 25 watts from this, and that is totally fine. You remember the minimum voltage was about 70 volts, so 78 is 4 volts more than the minimum we need to drive this amplifier, and that is with a 25 watt load, so I think this will be just fine. So that finishes up the testing of the power supply and all the components needed for the power supply. So next is the amplifier boards themselves, and I need to connect them up to some heat sinks before I test that. So that will be my next project, and hopefully now in a couple of days I will be able to fasten these on a sheet of aluminium or something so that we can get this test underway. So thanks for watching. Hope to see you again in the next episode of this video, where we will be testing the amplifier modules themselves.